So let's talk now about solutions. So a solution is a homogeneous mixture of two or more substances. So let's think of a simple solution. Say we have a beaker of water, and then into it we put, say, table salt, sodium chloride. So water is in the liquid phase, sodium chloride is in the solid phase. What happens to sodium chloride when it enters the water? Well, sodium chloride, solid, will, in the presence of water, dissociate into sodium plus ions, and we refer to this as aqueous, since it's surrounded by water, plus chloride ions. Now, once the sodium chloride has dissolved, you cannot see a difference in the phase. It looks just like water. So that's what homogeneous mixture means. It looks all as one phase. Now, the sodium and chloride ions are not just free in water. In fact, the sodium ions are surrounded by water molecules. And since sodium is a plus ion, the negative part of water, the oxygen, will point toward the sodium. And I've drawn 4 just for pictorial purposes, but the surrounding shell of water around the sodium ion is not just 4 molecules. So, there's an interaction between the sodium ion and the water molecules, so there are electrostatic forces holding the water around the sodium ion. And the same thing with the chloride ion. You have chlorine, and you have water molecules surrounding the chloride ion. In this case, I'm drawing the partially positive hydrogens around the chloride ion. And again, there's more than 3 waters around the chloride ion, but I'm just doing this for a simple picture. So these are called solvated ions. So there are interactions between the waters and the ions in solution. Now, these interactions are not bonds, chemical bonds. They're electrostatic interactions, and in this case it would be ion dipole interactions. We have an ion with sodium or chlorine, and we have a dipole from the water molecule.